Okay, hello, my name is Simon. I'm a cybersecurity engineer, and today we are going to look at a specific topic of microcontrollers. And here with me is an ESP32 board. An ESP32 board is a programmable board, and it has key features or key specifications. It has an SRAM of 520 KBs. It has a flash memory of 4 MBs, a clock speed of up to 240 MHz. It supports wireless, Wi-Fi, wireless connectivity, and Bluetooth connectivity, and many other features. So, in with us, the ESP board, on its own supports Bluetooth and Wi-Fi connectivity, though for a short range. And here with us is a small OLED screen. It's a colored OLED screen. And what this screen is doing, it's displaying whatever is happening here. So the board is programmed, but now the screen displays what the board is doing. And for this specific program that we've loaded on our ESP32 WROOM32 is a Wi-Fi scanning. We've loaded a code that allows it to scan Wi-Fi, and it displays the Wi-Fi it has scanned. So right now it has scanned 5 Wi-Fi networks. It goes to the process of scanning again, and I'll show you how it looks like, how the scanning goes and how it looks like. Yeah, because my camera cannot focus while I'm recording a video, so I'll do a separate video and add it at the end of this video so you can see how it scans. So the ESP32 is this programmable board, and we program it with Arduino IDE or any other online program, any other IDE that can be used. The ESP flash download tool, and there are other online websites that can allow you to directly inject code into this. So since the onset of AI, you can just come up with an idea, you go give AI the idea, and it can provide you the code to whatever you are doing. So what is needed most is your creativity. And here with me is an NRF. This is called an NRF antenna. This increases the wireless connectivity and range to 20 meters. That's the circumference of 20 meters. So at the point I'm standing, 20 meters, if you draw a circle 20 meters around me, that's the radius of 20 meters. If you draw a circle in the radius of 20 meters, this can be able to reach, or it gives the network signals ability to reach a radius of 20 meters. And today we are just doing a simple code. We are just scanning Wi-Fi networks. But now when we come to the cyber security aspect of this, so with me here, this full set, and this will be our motherboard. Once we finish programming and doing everything, we'll create a motherboard from this. We have these tiny, I call them tiny, these are buttons. Once we finish coding all the information we want, we'll create that one. These are cables, the ones I've used here for connection. And the cybersecurity aspect, we know of something called a flipper zero, very powerful hardware tool that can be able to scan, jam, copy, and do all those network hackings and all those jammings. And specifically, what we can do with this ESP32, we can create a marauder. And what a marauder is a small tool that can be able to jam Wi-Fi and Bluetooth signals. And this is done by a process called deauth. It produces so many signals that causes an interference to the existing signals. So I had already programmed it to do that, but now when we come to the wiring, this screen uses a 3 voltage pin here, and also in these wirings, the NRF also has a 3 volts. It also needs the power of a 3 volts. So, and on our ESP32 board, we only have a single pin for the 3 volts, and when I connect both of them on the ESP32, one will stop working. So I'm supposed to use a capacitor of 10 to 100 microfarads so that I can be able to run both of them. And this works for those who have done physics. It works. Capacitor stores charge, so whenever charge is being released, the capacitor is able to store charge. So these two can concurrently work at the same time using the same pin with the help of a capacitor. So this is our progress, and this is the scanning. It's scanning. It says scanning, and it produces the Wi-Fi networks available in my range. So that's the only capability it can do up to now. But we intend to I intend to make it more powerful by making it be able to scan, and using these buttons we can navigate to the Wi-Fi or Bluetooth signal we want to. The Bluetooth signal we want to jam, or the Wi-Fi signal we want to jam. But for Wi-Fi, I think for all these networkings, I think they are stray bullets, because when I'm creating a jamming signal and your Wi-Fi network is in the range, it means it will get affected. So I'm still working on it, but up to now, this is what we are able to see. I hope my camera will be able to focus. There's a problem with it focusing. So whatever appears there is scanning. That yellow is scanning. Then those fiber Wi-Fi networks in my range. I'll find a way to post whatever it's displaying, and it's displaying some of my hotspots and the Wi-Fi networks in my range. Yeah, and I think we'll be doing a daily update on what we are doing on this board, because this will be a motherboard. You see this part, this is a conductor. So we are supposed to shape it. We create a circuit. This is a circuit board. We create a circuit and we'll arrange all our components here and how they connect to these modules we have. And up to now, we're still ongoing. It's still work in progress. I believe it will be over. Yeah, so this is how our screen is displaying. So it has found Wi-Fi networks that are in range, and note that the NRF module is not connected. So it's just using the board. It's scanning using the board. You see, it scans. Now it's getting 4. It has found 4. It shows the strength of that Wi-Fi network, and this is what we'll be working on a daily basis. So I'll be uploading 2 videos on a daily basis, and yeah, that's for today's video.